All right. So definitely simplifying management. Like if you learn Kubernetes once, you can run. You don't have to learn other technologies, and which definitely helps many customers because they have to invest into just Kubernetes, not learning Hadoop all the way or bringing Hadoop experts or database experts. You can just manage all these applications on Kubernetes as a single unified platform. Revenue growth. I think most of you would have experienced that the reason we go to Kubernetes is because of containerization. When we come to containerization, we can bin pack, we can gain the cost efficiency. And that's really a driver for many customers when they see that by doing containerization of data workloads, which was not even thought of like when I was doing data, right? Like way back in 2017, that, containerizing a big data workload. We never thought of that, right? But we just threw many big machines to it, and the budget kept on increasing, and then we had to think of, hey, let's try maybe Kubernetes, right? Let's start containerization. And I've seen similar stories with big enterprises trying that even nowadays. Lastly, standardizing. You can standardize across hybrid, multi-cloud, everything on Kubernetes, right? In a single unified platform. And that has been the primary motive for many customers to just standardize on a single unified platform. And I'm going to bring up a story to you. One of our customer, Mobileye, they're Israel based, and they started their journey into Kubernetes a long ago, I think 2019, and when they migrated most of their web applications to EKS, and then they started migrating their data applications also. And they are a lot into machine learning and data analytics. So they started building a unified platform where you even start writing Jupyter notebooks hosted on EKS, and then you run Spark jobs on EKS, you run your machine learning, inferencing, training, everything on EKS. And then obviously Israel is a very competitive market, very cost sensitive market. So customers are more focused into, let's say, leverage spot instances, tools like Carpenter. And I'm going to talk a bit more about Carpenter. But anyone of you know about Carpenter? Okay, at least two. Okay. How many of you know about cluster autoscaler? I'm hoping all, right? Because it's a Kubernetes graph. So I hope all are aware of autoscaling, right? So Carpenter is an autoscaler, and I'm going to go into that, why it is critical, especially for big data and machine learning workloads. Now, with Mobileye, they brought in Carpenter, they brought in Spot, and they saw directly 50% cost efficiency, right? By just making these common changes, which are now best practices when you use EKS. Please feel free to read about their published blog, their published even testimony. There's a not so much on the microphone or on the call. Okay, sounds good. All right. So please read about Mobileye. So we have a blog. We have also a customer reference as well, which we have done with them on Carpenter. Pinterest is they presented in reInvent. They shared their story. So they are running all open source on Kubernetes, especially for their big data workloads. And what I'm covering today is actually similar to what Pinterest does, right? So Pinterest, they run actually open source Spark on Kubernetes, open source Spark actually on Amazon EKS. And by doing that, they definitely achieve cost efficiency, and they run at a very big scale. So many times customers ask, because these are open source tools like Spark Operator, can they really scale to a production workload, right? And this we are talking about 120 petabyte. In the region, I've not seen more than 30 petabyte, right? And they are at scale of 120 petabyte. So much bigger scale, up to 70,000 jobs, which are the daily jobs. So the scale is definitely there. Customers have achieved really big scales on Kubernetes. So you don't really need a full-fledged Hadoop implementation to reach these scales, right? Very well you can achieve on EKS as well. Now, data on EKS, if you're not familiar with this term, uh, so based on data on Kubernetes initiative, which is driven by community worldwide, AWS also wanted to invest into data on EKS, similar initiative. So what we have done is we have gathered best practices from our customers like Pinterest, Mobileye, and we have gathered all that best practice and we have come up with infrastructure as code so that if customer is trying something new, especially data engineers, right, they don't know what Kubernetes, they don't know what cloud, right? How can they get started really quickly by setting up a production grade Amazon EKS and then start running their workloads in matter of, let's say, weeks, right? So we have Terraform templates with all the best practices ready to go. And today in my demo, I'm going to use the same Terraform template to show you how quickly you can just set it up. And I've done the same as well for my demo, right? Uh, the next is performance benchmarks. Now these are critical for customers. They want to see, okay, let's compare Intel-based instances with Graviton-based instances. Let's compare, instance store backed EC2 with EBS backed EC2. How do they perform under a shuffle heavy workload? Right? So all those benchmarks we can do, we have shared some of these, and then also the best practices, right? To run Spark, Kafka, Ray, different ways to run Spark. So all these best practices are baked in. And finally, we also have deployment examples, architectures, so that even if you're looking to, educate your colleagues, you can share these as a learning as well, quickly setting up demos, showing all the architectures, examples. So all this is available on data on EKS. It's not a managed service, it's an open source initiative. And being myself part of open source, we have heavily invested into this. And this is like community driven by community like yourself, by solution architects like myself, bringing all the learnings together and coming up with an offering. So please have a look at it offline. It's a great initiative. Do contribute as well. Share your learnings as well in terms of blueprints, or if you want to, help improve this project further. We welcome everyone, and it includes not just data workloads. We are also publishing a lot of blueprints around Gen AI, like how to run LLM on Kubernetes. So all those good things are here. Please feel free to explore. Now today what I've done is I've picked one of this blueprint, actually two of the blueprints to set up Spark on Amazon EKS. Now before I go into Spark on EKS blueprint, what it does, because I'm assuming most of you are not familiar with Spark, right? Initially very few raised hands. So Spark is, at least few are familiar, most of you are not. So how Spark on Kubernetes works, but I'm hoping that most of you are aware of operators. So we have a Spark operator. It was created by Google. Now we have adopted as well as part of Kubeflow. Now, what this operator does, let's say, traditionally you do Spark submit, and then it kind of creates a naked pod, right? Then headless pod. Now, with Spark operator, you can take control of the entire life cycle. So instead of doing Spark submit and pod templates and all the complicated stuff, just create a Spark application, CRD, and in that we mention what is the Spark driver, right? Now, Spark driver, for who are not aware of Spark, is basically like a controller which will define how many workers or executors are required, right? So you have a Spark driver and then you have Spark executors. Together, you do distributed data processing. Okay, so similar control plane and worker plane sort of architecture, where driver is the brain of the application. Sorry, jumping forward. Now, how the Spark operator works, when inside, once the Spark application is created, it will do a Spark submit, and then you launch a Spark driver, which will request based on the application, how many executors you require, what type of machine, EC2 machine you require, and then autoscalers like Carpenter or Cluster Autoscaler will spin up those machines for you, and then you're good to go, right? So that's how the internal of Spark operator at a very high level. Now, usually when you're building data pipelines, you have Spark jobs, but these, let's take an example, you are applying a lot of filters on your data, and finally you have the clean data availability. So you have to create a pipeline, and to create the pipeline, you need workflow managers. Now, one of the very common workflow manager is Airflow. How many of you know Airflow? At least the Spark guys know Airflow. All STEML guys know Airflow, right? Now, using Airflow, you can create the pipelines or the workflows, and by creating that, you can, it's known as DAG, or dedicated acyclic graph, which basically means you have an entry point, an exit point, and there is no repetition, right? So you put a data, and then finally you get a clean data as an output, as simple as that. So together, these two Spark jobs and Airflow, you created data pipeline. So today, what I picked is, and there are going to be a few questions, so I'm just going to give one hint here. Now, Kubernetes scheduler is not meant for data processing, right? Distributed batch jobs. It's more of a sequential processor. Right? Now, what do we need here is tool like Unicorn, Volcano. Now, these tools can do batch processing, and you can override the Kubernetes scheduler. Now, with these batch schedulers. Now, Unicorn is not a new scheduler itself. It uses Kubernetes scheduler internally to do the actual scheduling, but on top, it can add budgeting. Might be aware of those words, right? Also, gang scheduling, how many pods should be scheduled together, right? Rather than waiting for, let's say, because in this case, let's take an example, right? Driver came up, and then you want to launch 10 executor together. The Kubernetes scheduler can't do all 10 together, right? If machine is up, it will start allocating immediately. But using, let's say, Unicorn, you can spin up the machines first and then start allocating together, so that you have more uniqueness, you have more uniformity while processing data. Okay, so uh, think of these as well when you're planning to run data workloads on Kubernetes, that Kubernetes scheduler may not be a fit, and there are a lot of community-driven schedulers which are available. I'm going to touch on Graviton definitely, because when we are running data workloads on cloud, cost is everything, because these workloads can, require many thousands of machines. Like we're talking about 70,000 jobs Pinterest does every day, right? So how many EC2s would that be, right? So maybe, millions of ECPUs or whatever. So if you don't plan for cost, this can shoot up really high, right? And Graviton comes really handy in these cases because it's almost 20% cheaper. It's ARM64 based instance provided by AWS as a custom chip named Graviton, and it is more energy efficient because ARM64 has been here for a while, right? It's in all Androids, even in the MacBook, which I'm sharing here today, right? So all these are running on ARM64. They're really energy efficient, and that's why we save on energy, we save on electricity, and we give back to customers as 20% savings. And also there's no multi-threading in Graviton, so that's why each core is actually a thread for you. So there is no multi-threading here, so you can get the maximum out of ECP core. And because of these benefits, it performs faster than Intel, it's cheaper than Intel, and matters a lot with the data workloads. Now, these are the learnings from all the big scale customers, right? When they run Spark on Kubernetes, what are the best practices? If you're doing same, you're aiming for production, what should you be looking out for? Now, this story could be really common. Uh, Infrastructure is, or VPC networking is set up by someone else, let's say a different platform team, and they were very greedy, right? With their VPCs seeder range, right? They gave you very small. They didn't think you're going to run a big data application, and now you're bound to a very small seeder range, and you can't really spin up many machines. You have to launch either very big machines because you have very less IPs. Very common issues we have heard from many customers because of whatever the reason is, someone else set it up. That's usually the outcome of the discussions, right? So the best practice here, what we have seen, is create a secondary seeder range and just allocate that to the executors, right? Now, you can definitely run your internet-facing, your mission-critical application on the primary seeder, but all the data processing executors, let's say even in the ML side, right, machine learning side, all your training jobs, you can run on the secondary seeder, and which can be as big as possible, like /16, so you have a really big range available to you. That's the first best practice whenever you think that, hey, I can't run beta workload on Kubernetes because I don't have IPs, do a secondary seeder. Core DNS failures, many times we don't think about core DNS because we really are running small workloads on Kubernetes. But when we're running really big workloads, we have to start thinking about how to horizontally scale the core DNS, right? And for that, we do have cluster proportional autoscaler, which can scale the core DNS for you. So a very small thing, but really matters, especially in a large scale workload. Spark Shuffle, those who are not familiar with Spark Shuffle, you might be familiar with disk operations. So Spark Shuffle is basically when you are writing a lot of data to disk and you are spilling to the disk, right? So how Spark works is in memory. Everybody thinks it's just in a memory. It will never talk to disk, but it does, right? If your memory is full, then it will start spilling to the disk. And this happens when you do complex joins. You are scanning across many data tables, right? And by doing that, you're doing shuffle, which is a very common wide transformation in Spark, and which leads to disk spills. Now, whenever you are heavy on disk spill, think of instance store. Now, if you're not aware of instance store, it's all the D type instances. So the D type instances means you have instance store backed AMI, which means you have a disk. Let's say within your laptop, you have a disk, right? That is instance store. If you are connecting external hard drive, that's EBS, that's external. Obviously, it's connecting over a port, so it's a bit slower than what you have within your machine. And that's why instance store is really recommended for workloads which are very heavy on spill. But not for every Spark job is not shuffle heavy, right? So we have even seen 90% of the time these jobs are not shuffle heavy. So these can really work well with EBS because those instances could be slightly cheaper because whenever we attach a disk, is slightly higher price, right? So you can just go with this known instance store based second example, right? Known instance store based EC2 and then attach a disk based on your requirement. It could be as small as possible. Now, the other benefit is because now your storage is outside your instance, even if the instance is interrupted, let's say you're running it on spot instance, right? And the instance is interrupted, your storage is outside. And in Spark, 3 years ago, we invested into uh, apologies, reuse persistent volume, reuse PVC, which means here, if one instance goes away, there is a EBS attached. Now, this EBS persistent volume claim can be claimed by a upcoming executor. So your data is secured, it is still there in EBS, and it can be reused by the next executor. By doing this, you are improving the resiliency of, of your Spark job, and that's really critical when you are running on spot instances, which where interruption can keep happening, right? But again, like I said, there's a trade-off. If you're going with this architecture, and if you have heavy Spark shuffle and spilling is happening all the time, may not be an appropriate architecture, right? because every time you have to write to a external disk, and that could be slow. Okay, so let's look at compute options. So what we recommend is what we are seeing with customers. Driver is a brain, right? Is essential component. If it crashes, you lose the job. So run the driver always on demand. Don't run it on spot. Executors, even if they die, like I mentioned earlier, you don't lose data. You can spin up a new executor, use the same EBS volume, or even if you're running a instance store based EC2 for your executor, even if it crashes, right, you just lose the data for that particular workload. So that's another best practice. What we have seen is usually when we are coming from data background, we really don't think of overheads, right? Overhead means it could be all the packages, Python packages we install, and also a lot of these packages might be running the as in the background in the container, right? And we forget to attach the overhead factor here. So we highly recommend attach like 10% overhead. In case of Python, it can go up to 40%. So when you basically in your container, when you're sizing it, mention that you need 40% more memory because there could be a lot of dependencies which are running in the background so that your container doesn't go out of memory quite often. So also about Carpenter, Carpenter, I didn't mention earlier, but now I want to go a bit more deeper into Carpenter. Now with cluster autoscaler, it's more meant of, and I think it was uh, when community invested into it, they just thought of autoscaling groups, which is basically, hey, you're running a web application, all your containers are same sized, and your EC2 instances are also same size. So cluster autoscaler recommends you to create homogeneous autoscaling groups, which is not great for data workloads. One Spark job needs only one CPU, another job needs 10 CPUs. And now you're stuck with two different node groups. What if you're running different types of jobs, like 70,000 jobs, and all of them require different vCPUs? You can't create like hundreds of node groups, right? Or auto-scaling groups, which is really big overhead. So to avoid that, Carpenter simplifies everything. Here, just one example, I just mentioned I need R, C, M. These are the three instance types. All my jobs can fit based on the VCP to memory ratio. And I'm just going to define in my job that it is 2 vCPU, 8 GB RAM, and I'm not going to create an auto scaling group. So Carpenter will look at the application and spin up the instance immediately for you based on what your application needs. So simplifies that a lot. It's more application first rather than infrastructure first approach. So just define in your application, size your application correctly, and then Carpenter will launch the most or best fit instance for you, achieving the maximum cost efficiency. I already spoke about batch schedulers. I'm going to skip that. We're a bit tight on the time. But I mentioned that Kubernetes scheduler is not that great for batch workloads, so we definitely recommend Unicorn and Volcano. We will take one more minute and just do a wrap up. Uh, there are other tools which are really critical for, let's say, Spark for observability point of view. So you can capture Spark metrics like JMX data and push it to Prometheus and then plot it on Grafana. And that's really helpful to set up observability for Spark application. And a lot of customers are after this as well, right? Now, Spark History Server, you can run it quite easily as a pod or even behind a node network load balancer in EKS. So it gives you a nice view of all your Spark jobs, right? And lastly, you have for the logging, you can use Fluent Bit. Using Fluent Bit, you can push the logs to the CloudWatch. If that's too costly, maybe to the S3, right? And by doing that, you get the end-to-end observability for running a big data workload on Kubernetes. With that, I don't think we have enough time to do a demo, but if you're interested in this blueprint, do reach out to us and do just go explore data on EKS. And if you look at the blueprint, it really explains all of this to you. So you don't have to really worry about these slides. It's all there on open source, it's there on GitHub. With that, thank you so much for your time. I hope this was helpful.
Share your text. Where you're presenting.
Sorry.
Okay, yeah, you'll see.
This is, I see myself, right? Was it? Cool. Okay.
Thanks. And this is all.
Okay. Hello. No, you come. Right. Hi, everyone. Thank you all for your times coming down today. My name is Sai. I work at HashiCorp as a solution architecture specialist, and I focus on the HashiCorp secure product lines called HashiCorp Boundary, Console, and HashiCorp Vault. So today, what I want to talk about is like how do we secure access to Kubernetes using the HashiCorp Boundary, even though it's like Kubernetes, but HashiCorp Boundary can secure any targets, like any TCP targets, your Linux boxes, your Windows machines, your databases and stuff, and how do we do that securely? So before I talk about that, anyone heard of Terraform? All right, thank you. So what about anyone heard of like a HashiCorp Vault? Oh, all right. Cool, yeah. What about HashiCorp Boundary? No, right, cool. I picked the right topic. Okay. So yeah, before I talk about that, I would like to spend a little bit about like what is multi-cloud security in the zero trust world. So if we take a look at the security, right? So there's 4 pillars. The first one is around, we all familiar with like human authentication authorizations. Any enterprise company, we have like an identity provider, like your Microsoft Azure AD or your Ping identity or Okta and stuff, right? So that's where we have an first line of like a security, so that we have to authenticate, so that we can do whatever that we want to do, right? That's the first round of human authentication authorizations. So the second aspect is around machine authentication and authorization. Machines here means that your applications, your microservices, containers, VMs, et cetera, right? So then how do we, like, have you ever think about, let's say, if you have very simple example, AWS access key and secret access key, right? Well, if you think about from the security perspective, what do you see for security, AWS access key and secret access key? But I'm just giving an example. It never expires. And if you want to rotate it, you have to delete it manually and you have to recreate it again, right? So what if we can rotate automatically, delete automatically, and also what if we can time bound? That means you can only access that, you can only use that access key, secret access key in a certain time without any human interventions, that you can do automations, right? And also, what if it will be more secure, the access key and secret access key or your security creature does not exist if you don't need it? That means like on demand, it will be better, right? So all of those security principles, then how do we do that? We can do that using HashiCorp Vault. So another one product is around like a console, which is like, anyone heard of, familiar with the service mesh? Right, so like it's still, you know, console, Linkerd and stuff. So which is around like one of the security products. Another one, the one that we're going to talk about is a human to machine access, which is HashiCorp Boundary. So the objective is around like, what if, as I mentioned earlier, what if your access is to access your private resources? Let's say, example, your database, your Kubernetes clusters, RDP machines and your Linux boxes and stuff, what if the access is granted only just in time? And then secure your whatever security credentials will not create unless you needed it. And then when you use that credential to access it, and the moment you've done your job, everything is just right. You watch like a Tom Cruise, what is it, Mission Impossible, right? The first scene is, have you heard of that? That is everything about zero trust security is there from the Tom Cruise movie, right? You listen the message and everything is just right. So ephemera, everything. That is one of the around this principle, security principle access itself. So, right. So what do we what is the current problem today of accessing our private sources? Yep. How do we access? Let's say you have your Kubernetes cluster EKS in your private subnets, and if you have your Linux boxes, Windows machine databases in the private subnet, how do we access normally? We're going to have a jump box or bastion host in the public subnet. You jump onto that machine, and then after you hop, right? So from that perspective, right? Which is not point-to-point access. What do I mean is that the moment you gain access to your jump box or bastion host, you have access to the whole network. Because the network, like the subnet, private subnet and public subnet can talk to each other, right? So what if we can only give access point to point? Let's say you just need to access to the database. You are just go to the database, access it, your security credentials and stuff is on demand. The moment you end your work, everything is destroyed, right? So to get that, to achieve all these kind of things, what we have a problem today is the bastion host access. Another one is around, like, we will have the VPN to access it. You use a VPN to access your private resources stuff, right? And then we all do that before, or maybe I'm not sure you still do that, right? So yeah, this is a risk, right? So that is how do we access our private resources in the traditional access flow is you connect with the VPN or your SSH bastion host or your jump boxes. And then maybe you will have somewhere along the line, you have your firewall, firewall rule that to prevent it. And also you will have like your PAM solutions, maintaining your access control about who can access what and stuff. And then you use the credentials finally connect to your the final target, right? With your database or Kubernetes cluster and whatnot. So this is the traditional workflow. So as I mentioned earlier, if you don't remember anything today, it would be great if you remember this 6 concepts. The first one, principles of least secure access, least privilege. We don't need to give access like if you don't need it, right? You just need to access your Kubernetes cluster. You just need to do the kubectl get ports command. Just get that. Don't give more than that, right? Another one is generating on demand. So your security credential don't exist before if you don't need it. And if you need to access it, generate it. Another one is around point-to-point access. As I mentioned earlier about the bastion host, instead of giving the whole network range, why not just give a point-to-point access to the target that you want to access? Another one is a time bound, which is your security credential, right? So it only lasts for, let's say, example, you need to do the job for 5 minutes, your security credential only valid for 5 minutes. And then, of course, never share. That means, what do I mean is that, let's say to access your security, to access your target, your resources, you're going to be doing your authentications, which is your corporate identity, maybe Azure AD or Okta or Ping Identity or your identity provider, LDAP or OIDC. And with that, and then you're going to have the policy defined that what you can access. That means you can access to maybe 5 different targets: database, Linux boxes, and Windows machine, and your Kubernetes clusters and stuff. And with that, you will get your credentials, and you never share your credentials. If you need to access again, you're going to authenticate again with your corporate identity provider, and then you get your credential again, and then you access it. Another one is ephemera everything, right? Because in the cloud, everything is dynamic. Like Kubernetes pulls it up and down. AWS resources are up and down. When the moment Kubernetes port is down, and when it's come back, it's a different IP address, right? So it's ephemeral, right? Very dynamic world in the cloud era today. So yeah, so these are the 6 principles of secure access. So with boundary, we can achieve all of those. So yeah, let's say if you take a look at here, user gonna have the first thing that what the user needs to do is the user need to authenticate with your identity provider. I'm sure all the enterprises already have the identity already established, either your ping identity, Alter, IDB, LDAP, or etc. And the moment you authenticate it, and then you're gonna have the policy defined that what you can access it. And then you can connect all the resources, and then you can connect it, and then you can access all your resources. Okay, so this is another simplification of the workflow. How the boundary works is boundary have this controller and worker concept. Let's say if you think about it, you have your final target that you want to access, your Kubernetes cluster or your Linux boxes, your database, right? And then those targets, this is the, you can, if you take a look at here, your targets, your Kubernetes cluster, pods, and your application and database, right? Those targets will only be able to access through the, what we call a boundary worker. Most of the enterprise organization doesn't allow the inbound network connectivity, right? So boundary worker, you don't need the inbound network connectivity. And so from the boundary client here, it may be your desktop client or it will be your CLI. Boundary clients comes with the 2 flavor, desktop and the CLI. I will kind of demo later. And then your user here, the first thing the user going to do is the user going to authenticate with the boundary controller. The boundary controller going to delegate your authentications to your IDB, right? And then from there, based on the policy that you define, you're going to get a list of targets that you are able to access it. From there, and then we can integrate with technology tools like a HashiCorp Vault, where it will manage all of your credentials on demand. That means the secrets, the security credential won't create it until you request it. The moment you try to access your target, the boundary controller gonna talk to HashiCorp Vault, get this credential, and then it will inject in the session that you're trying to access to your target. And then the moment you end your sessions, the credential is destroyed. So everything is automated. So this is around the workflow. So here, I'm gonna demo here. So as I mentioned earlier, in my setup, what I have is like a boundary controller, and then I have a bunch of targets spinning up on the AWS. If you take a look at here, I have boundary controller, I have the boundary walkers, and also that I have like Bastion host here. I just spin it up just to manage my instances. And I have different machines like a Linux, Windows. I have database, and also I have my EKS cluster as well. So everything's, and another thing is about everything can be automated using Terraform. So I spin up the whole environment using Terraform. Right, so this is the boundary client, desktop client. Let's say here I'm gonna be I will show you how. So right now, what I'm gonna do is I open up my boundary client using the desktop client. I'm gonna be using my boundary admin. So I authenticate using the Auth0. In boundary support, 3 different authentications mechanism. One is like a username, password stored in the boundary. Another one is you can delegate your authentications to your IDB provider like Okta, Ping Identity, or Microsoft Azure. They call it Entra ID right now. So the moment we authenticated, I have a list of targets that I can be able to access to. Let's say example, if I log out, this is because I log in as an admin, so I can see all of my targets. Here I have my EKS Postgres database running on the EKS. I have my Windows machine, and I have my Postgres database, and also I have my Vault Enterprise, and I have my EKS as well. So let's say if I log in using, I set up like auth 0. So it will delegate my authentications to the identity provider. So let's say I'm gonna log in using admin. So my authentication is successful. So with that admin, so I can only access to this organization's called like this business unit called digital channels, and I can only see only 4 targets that I can only access it. Cool. So right now, what I'm gonna do is I'm gonna use the CLI. Zoom in, all right. Okay, is that okay? Better, cool. So this, I already authenticated to the boundary, just now the manual process that I've done. So I'm gonna run the scripts to authenticate and authenticate it. Cool. So after I authenticated, I can see what are the targets that I can access as I show you earlier in the GUI. So now after I run this command like boundary target list, and then I can see all of my targets like for enterprise, I can see my EKS clusters and et cetera, et cetera. Okay. So after I've done that, I'm gonna get to access to the Kubernetes clusters, we need, how do we normally access it? Kubeconfig, right? Yeah, kubectl, and kubectl gonna talk to the kubeconfig. Kubeconfig, how many information do we have to access Kubernetes clusters? What are the information that we need to access your Kubernetes clusters? 3 information. The first one is your Kubernetes API server IP address, right? And then second, certificate authority of your CA. And then third is service account, right? So in Kubernetes service account and identity, the service account gonna bind to your cluster rule and cluster rule binding, and that's where all of your what you can do and what you can't do using cluster rule binding, and then access and tied to your service account, right? So in here, what I'm gonna demo is I don't have that service account created on at this moment right now. So it will only create when I authenticate it, and it will create automatically. So that service account can only do kubectl and get pods. That's it. It can't do anything more than that, right? So this is what that's what I'm going to demo right now. So if you take a look at here, I have this the credential folder. I don't have anything. So what I'm gonna, the moment I run that the authenticate to my cluster, then it would generate that something like a kubeconfig file, right? It would generate automatically. So now I don't have anything right now. So I'm gonna run my script, which is basically like getting that Kubernetes cluster and stuff. So it generates to my config file, right? So I have this terminal right now. This terminal have access to my Kubernetes cluster. I have the full admin access it. So if I do like kubectl get service account in my test namespace, so you can see that this token is generated. So this is a token, this is a service account that I'm going to use to access to the Kubernetes clusters. This service account, service account is created by the HashiCorp Vault automatically on demand. So I'm going to And also, another thing is this service account is only valid for 10 minutes. It won't last more than that. Okay, so I'm gonna watch it this one right now, and what I'm gonna do is my cluster. Okay, so if I have access to kubectl get pods dash and test right now, and I can access it. Let's say example, if I do kubectl get service account, I don't have access. So let's say example, this is this situation of, let's say your developer, you need to check, you need to access some of the things, and then you can only access to that particular namespace, and you can even like you can only do like kubectl get pods. You can't do more than that. So okay, the moment another thing that I can share with you is if you take a look at that kubeconfig that I use here, I'm talking to 127.0.0.1.53240, which is just dynamic pod. So I normally, if we have access, you have your Kubernetes API server, right? The URL, and then you gotta access it, right? So this is, and then let's say the moment your 10 minutes is you reach your 10 minutes, and then this session is gonna destroy. This session gonna destroy, and then when you want to access again, you gotta authenticate again, and it will create the service account credential on demand, and then you do your work. Yeah, so this is around like an on demand ephemeral everything, and also it only lasts for your security credential is time bound. So yeah, I only have another 3 minutes. So, but I prepared a bunch of test cases, but like I only have limited time, so I couldn't able to demo it. So another thing is around like let's see here. I have another one here. The SSH target. So this is trying to access to my Linux machine in the private subnet. So how it works is that the boundary client gonna talk to the boundary controller that I want to access to that private Linux machine on the private subnets. So how it works is like this boundary, the client gonna be establishing a secure tunnel to that worker in your Ilbus account, and that tunnel gonna establish to that worker gonna establish another secure tunnel to your target. So that's why if you think about it, boundary is acting like an identity aware proxy. So normally if you try to access to that Linux machine, then you need like SSH certificate or SSH key pair, right? So in this case, I don't even need the SSH key pair or SSH certificate. That SSH key pair or certificate is automatically generated from the vault, and then vault gonna inject to the sessions. So you don't even need to touch it. What we call it passwordless access. So I can demo as my last demo here. So yep. So I'm in my Linux box. If you take a look at here. So now I have three sessions that I'm accessing to. The first one is around my HashiCorp Vault, which is in the private subnets that I don't have an direct network access to, which is using the local host and entering the dynamic port. And this is my Kubernetes clusters that I'm accessing to, and this is my Linux machine. So if you take a look at the boundary client, because I access my targets using the boundary admin. So I'm gonna log in using admin. Now, if you can see that I have 3 sessions I'm accessing to. So, yep. The moment I kill this, if this is hits to 10 minutes, so I can't be able to access my Kubernetes cluster anymore. So to be able to simulate that, I'm gonna kill that process. I think this is using 53240. So 53240 process is this one. So that session is gone. And then when I try to run kubectl get pods, I lost the connection. So then if you take a look at your Kubernetes clusters, so this one were gone after 10 minutes. Then if I want to access it, I need to establish the sessions again. And then so that it would generate that service account, another brand new service account, and then you can be able to do your work. So, yep, with that, thank you all very much for the time. And if you have any questions, feel free to, yep. Thank you.
Ansible, yeah.
Good evening, everyone. So we have a small topic. Oh, 20 minutes. Okay. Okay. My name is Gineesh, and yeah, I work for most of the Ansible plus Kubernetes stuff most of the time. So this topic is something, how to say, it's not that complex one. It's very simple tool. Actually, it's already available. We will start with some basic things about what is event-driven Ansible and why we are using or why we should use Ansible, event-driven Ansible for the Kubernetes task. Okay, we know Kubernetes is doing a lot of automation. Let's see how. So we have this talk everywhere. So we say, okay, we have a lot of BC time with the BAU because I don't have time to do the automation. And I am working on the same repeated task every day. Okay, there is a problem. You log into the server, check the logs, fix the issue. Okay, you know there is a log file, there is something else. It's always same, so it's all kind of a boring. And you have a lot of thousands of other false alarms because most of the time there will be a lot of issues. The tickets are like thousands of tickets in the system. Now, what will happen if there is a problem, right? There is a issue. Maybe if you have a monitoring system in place, it will generate the alert in your monitoring system. Maybe it will be notified with some IT support guy or the server team or maybe the Kubernetes admin. Then you go and check the issue, then assign to someone. Okay, please assign to this guy or this guy in the support ticket or support team. Later, whenever the person is free, the Kubernetes admin or whoever is free, then they log in and fix the issue, update ticket. How much time it will take? An average. Good one. Yeah, it will take time because of course the support team is always flooded with the tickets. And most of the time, okay. Pop up? Oh, okay. Okay, no, thank you. Yeah, because the problem is a lot of formalities there. Someone need to log into this because you are working on the support portal more time than the actual technical thing, and you are doing the same thing again and again. boring, I know. Let me try to move this one as well. Okay. So we have this environment where we have our applications, our platforms, our infrastructure, then the security thing, we have our network, then we have our Kubernetes, OpenShift, everything around, and we have the support team or the operation team, the BAU team. It's not easy to coordinate because support is the important one. Because once the system is live, you have this problem because they always talk about the uptime. They always talk about the uptime because when there is a new system in place, you enable the support. That's what we call like a production cutover or go live. Right? What if you can make this something simple, right? Assume we have some automated operation in the middle, which will detect these issues and enable some kind of automation to do the remediation or troubleshooting everything for you. Okay, this is where we just introduced something called event-driven automation or event-driven Ansible, whatever we call. Yes, we have a Kubernetes. We will talk about that. Now, why and what? So Ansible is, of course, we know the open source automation platform used for configuration management, deployment, orchestration, and you can do it for anything in IT. Okay, trust me, you can do it for any automation. It's YAML-based, human-readable playbooks. Of course, agentless. You can execute via SSH, WinRM, API, and other Kubernetes-based connection protocols. What is event-driven Ansible? It's basically we are automating the task in response to real-time events. So you have monitoring in place. You don't need to replace anything. You have a monitoring in place, and you have a logging system. You have a lot of agents running for the monitoring. Maybe you have some local, maybe Falco agent. You have some Kubernetes alerts, Prometheus, everything in place. So we need someone to take care of these logs, understand the logs, and do some kind of automation. That's what EDA is doing, the event-driven Ansible is doing. So for the typical event-driven automation, this is a process. So you have some event sources. It can be your Prometheus logs, it can be a system log, it can be Kubernetes logs, it can be anything. Then you have some rules. Okay, if these, then do that kind of condition. That's a rule. Then you have a response or kind of action. What should be done if the rule matches? Okay, do something. And it should talk to all the devices. It should not be like red devices or blue devices. It should be able to talk to the other platforms, vendors, different devices. And this is a key concept of event-driven Ansible. So you have the sources like plugins like Kubernetes, it can be Prometheus, it can be custom webhook, it can be anything. Then you have rules, which basically the conditions like CPU load is something like this. If there is a new configuration map updated, if there is the user login, if someone login from specific system, everything you can create the rules. It's all customized rules. Then you have actions. You can maybe notify, send an email, maybe do something, or can be a playbook. You just run another Ansible playbook or trigger some API call. It can be anything. That's action. So rulebooks are basically the YAML file where you write your event sources, rules, and actions. That's it. So I mentioned if this, then that. That's a simple logic. Now, how it looks like, it's very simple. So you have a rule like check for folder modification. So you are waiting for a condition here. So you have some event source, which is taking care of this monitoring, able to detect this kind of event real time, and it's just feeding the logs. Then Ansible rulebook, you have this condition here. If there is a folder modification, it's all regex actually. Then there is an action, run the folder permission restore.yaml. So if someone change a folder permission, for example, this is a sample. There's another case, let's say you have a Kubernetes deployment where your config map is changed, but your deployment is still running. No, who will update it? So you can automate, yes, Kubernetes, you have some options available, but generally you can do that kind of automation. So it's more like ops to AI ops or whatever the name, because we can put AI ops everywhere. Now, it's very simple. Just think about this. We have an event, you have a problem, you know the solution. You don't need a human to do that. I mean, you don't need an engineer to do that. Let him focus on other things. So you can automate that operation by simple rules. Now, in Ansible rulebook, again, I mentioned you can write your rulebooks as you want. So you can add your sources, event sources here. It can be an alert manager, it can be a Kubernetes source, it can be a Prometheus one, it can be anything. You can write your custom rules. Basically, if you know Python, you can easily develop. Just ask ChatGPT, will it will give you the simple code to how to read from event source. Then you have some rules. Okay, if there is a, for example, on the screen, right? If there is a alert with a labels.job fast API, then you can combine the rules. So you can combine the conditions, like it should be fast API plus if the status is firing, that means something wrong. What you can do? Start the application. So there is something wrong, the application is not working, you can start it. This is another one, using the watchdog, where you have some additional option, like you can ignore some of the rule. You don't want to read all the logs. You can put the regex and remove or ignore some of the logs. Then you have other conditions for directory modification or folder modification, add some files in a specific folder, which is not allowed. Everything can be monitored and restored back. So it's very good for your CIS or kind of compliance use cases. So EDA use cases, actually, there are a lot. We mentioned the ITSM and ticket automation. Very simple, because I think 90% of the tickets you can automate, because we know the problem. You have to go here, you have to do this, you have to do the second step, third step, and it will be done. The problem is you will take another 30 minutes to update your ticket. Copy paste the logs. Okay. Then there is one is this one called workload management. Let's say you have application requirement, like in the earlier session they mentioned the Carpenter, you have a KEDA, you have a lot of tools available for the cluster deployment. But some cases you don't have that mechanism to provision the nodes in a bare metal situation, or can be a new platform where you don't have a Terraform based operations. You can use Ansible to provision and do it. That's a good thing, or any tool. So the question is, Kubernetes can do a lot of automation. When there is a workload, you can do the auto scaling. You have a HPA, you have a vertical auto scaling, you have a horizontal auto scaling. Everything is already there, right? There are a lot of tools available. Why Ansible? The first answer is like it's Ansible can do a lot of things beyond Kubernetes, because Kubernetes is talking about its own area. That's just a cluster. Ansible can do the cross-platform automation. It can be your network device. It can be your firewall, load balancer. It can be your cloud platform. It can be anything. Then the good thing is like the event handling can be outside of Kubernetes. So Kubernetes is doing this based on the existing metrics and some other custom metrics. But Ansible, you can use other external metrics, monitor it, and trigger some automation based on the rules. And of course, there are other advantages like workflows. You can create your, you can automate your legacy system, like a bare metal servers can be something related to the Kubernetes automation. Can be anything. Maybe you have some Oracle servers running, which is not in Kubernetes, but you have applications using that, then you can do something like that. So for the event-driven Kubernetes, how it works, basically you watch the Kubernetes and external events. So you have Kubernetes events. You can also watch external events like a pod failures, CPU threshold, can be anything. Then automates the remediation. It can be scaling, it can be a redeployment of the application or scaling down or blue-green deployment. You increase the percentage here, decrease the percentage. It can be anything. Don't get confused. I'll give an example here. Sorry for the, don't know how to move this one. Okay, not good. Okay, so we have a scenario. Let's say a very simple one. Okay, we don't want to discuss a lot of complication one. We have a config map update. So whenever there is a critical config map update, you are supposed to redeploy the application. Okay, by default, it won't be there. You can use any tools, but let's assume how we can detect these config map changes. The solution is very simple. We will monitor the Kubernetes events and detect the modified or added or deleted kind of events from the Kubernetes events. You have a Kubernetes source event plugin, community plugin available. Based on the trigger, based on the rule, we will trigger some playbook to automate the redeployment. Can be some OC rollout command or sorry, kubectl rollout command, and scale down or scale up the deployment. That's it. The benefit, first thing, you don't need an operator or Kubernetes administrator to go and do the redeployment. Secondly, you don't need someone need to monitor all the time, right? There is a config map update, not easy. Maybe there is a situation you have to take care of this automatically, so you don't need an operator for that. For something like complicated one, we have Prometheus. This is a sample one. So you have application, you have a metrics available from your application monitoring, you have a for the Python code, every application running. Then you have a Prometheus running with all your custom alert rules. Then you can trigger the alerts based on some rules. Then it will also use webhooks, or it can be some middle event source system. It can be anything. We don't need any specific, it can be anything. Then Ansible EDA or the event-driven Ansible will just monitor it. And based on your rules, if the rule matches, it will trigger some playbooks to remediate the issue or redeploy the thing, or it can be anything. So for the cluster management, as I mentioned, yes, we have the tools available for the cloud because it's easy to redeploy or easy to provision or deprovision the nodes. But with Ansible, you can also enable this node provisioning, configuration of your operating system, some hardening, can be anything. This is a DR kind of a demonstration for OpenShift cluster, where you have multiple clusters in DCDR situation, and based on some CPU threshold, based on some other event, you can trigger the DCDR movement using the event-driven Ansible. So it's based on the logs. Of course, we have to catch the events, catch all condition. If all condition means okay, we can use some automation from the hub cluster to the second or the DR location. So this all by default, I mean, even from the hub cluster, you can manage your, let's say you have some load balancer or you have some LTM, GTM kind of configuration. You don't need an operator because Ansible can handle that GTM updates. Let's say you have a FI load balancer on the top talking to the DC application now, but it's already DR. You can move to the DR. You can point to the DR. So DNS update can be done automatically. Think there are a lot of use cases for the Kubernetes, not just Ansible. I'm just talking about the Kubernetes. It can be failover between the clusters, continuous deployment pipelines based on some trigger points. Then can be instant response. It can be compliance. Can be anything. Basically, for Kubernetes, we have the Kubernetes core collection available to manage the entire Kubernetes platform. And also there's an OpenShift one. So you can see a lot of plugins available. One is talking. And for the connection, you can use the token or username. It's already available. It's very easy to use. For the event sources, there are a lot of sources available. By default, the collections already contain the event source plugins like CloudCasa, you have Dynatrace, IBM Dynamic, Instana, Palo Alto, etc. And for the enterprises, of course, we are talking about enterprise platforms. So you can integrate with your Ansible automation platform and EDA. From there, you can manage, because we are, for the enterprise, we are talking about RBAC, we are talking about credentials, we have a lot of things to manage, integrate with your enterprise platform, or we can use a normal rulebook, which we will try now. So what we'll do, we'll just a quick demo. Okay. Is it readable? Readable? Good now? Okay, right? Thank you. So we have a rule book here. Okay. Okay, so we have a rule book here, which will take care of the Kubernetes events. So it's using EDA.K8S module. Basically, it's an event source plugin. Then it will search for or it will monitor only the config maps. Then we have a rule to notify, which will actually check if there is event type is modified or added. So for the demonstration, we will use the modified one. If there is a change in the config map, we want to execute a playbook to fix it. Okay. It's a very simple, I don't want complicated one. Okay. So we have an application, very simple one, running here with interest. What we will do. So from the command, we have to run Ansible rulebook. It's not a one-time, guys, just like it's running in the backend continuously. Okay. So I enable the verbose mode to see the logs. Now, how to test it? It's very simple. Maybe you can. Okay. So I have a config map here. Then I am just changing the config map. Okay. Just for the demonstration. Okay. Then I apply it. So what will happen when I apply it? There is a change in the config map, and on the left side you can see the event-driven Ansible or the Ansible rulebook detected it. It found there is a change. It triggered the playbook. That's it. It's real time. Depends on your application. It will take some time to redeploy the application or this thing. Now let's try it again. I want to change it to shopping portal and maybe red. Save it. So every time when there is a change in the config map, you can configure your config map plus the application, all the mapping. This is just a demonstration for the config map change. It can be anything. We go and check. The application will be updated or redeployed. Depends on your playbook. Okay. So this is a very small demo for the config map changes. But if you have a event-based one, let's say you have a Kubernetes event issue, then there is something like a pod is not working, this one is not working, then you can monitor that and you can write, of course, you can write the complex playbooks here and manage your entire cluster, like can be anything. So here I have some samples for some just display the information, or it can be sending some Slack notification, can be anything, because Ansible can talk to almost anything. Good, that's it. And anything else? Yeah. So I have some references. I will share these later. You have some OpenShift based and Kubernetes based demonstration as well. Also, there is a lab to test the event-driven Ansible using Ansible rulebook. It's free, it's public. Utilize it. And that's it. I think we don't have time for questions. Yeah, if any question, please let me know. I'll be around. And I think that. Thank you. Thank you.
Thank you, Gineesh. There is another program that you touched, that is AWS Thoughts. So this program is just like the GitHub, we have certifications. We have the AWS chief all the certification. To get this golden jacket and be got Whoever wants to join this meetup as a speaker, a volunteer, or a sponsor, can be your host. You can be a speaker, you can be a speaker, want to be a volunteer, you can stand or sponsor. Yes. You can follow us in LinkedIn, Twitter, and Eva. Subscribe and we can give you updates. This one and also you get all customer companies. You are inputs are right and your contact right. And yeah, add that's okay, so now we have a fix. I hope you have all these things, but it will be of that. And yeah, first that
QR code, right? Scan the QR code.
yeah. We have two core cloud subscription and then 50% Kubernetes certification courses.
Everyone joined?
No.
Anyone has any trouble joining in?
We still have many people to join. 50 for now. I think 30 more. Okay. All set. Can you start? Or anybody yet to scan? Okay. So watch your mobile. Started, yeah.
Sorry, please go ahead.
There is a timer for each individual piece question. Great, we have 70 participants. Okay, so we have CM 11. Okay, so hope you have registered with the correct mail ID. So it has to be matched with your mail ID and the name. Okay, so next question, be ready. What tool provides the best option for auto-scaling Kubernetes cluster with the flexibility and diversification, prioritizing applications and resulting in cost savings and increased availability? Okay, well done. 79%. Carpenter, yeah. Okay, ready for next? Ready for next question? What are the primary use cases for Ansible? Okay, 55% still can add real and Asanka. Okay. Okay, ready for next question? Oh, that's not bad. People, 37 participants did right answer. Okay, ready for next question? Okay, well done. 42 participants. Okay, 4 more to go. Next. Why use Ansible for Kubernetes if Kubernetes has automation? Okay. Three, two, one. Wow. 50 participants did. Correct answer. Okay, so next question. Which of the following is not a typical use case for event-driven Kubernetes with Ansible? We still have Kensi, CM11, Akanka, Asanka, or leading. Oh, okay. Kensi is leading now. Asanka and CM11. Good luck. We have 2 more questions. How does Ansible handle event sources in event-driven automation? Five, four, three, two, one. Oh, well done. 61 participants did correct answer. Okay, last one more to go. Which of the following best describes the role of rulebook in event-driven Ansible? Kensi is still leading. Okay, that's great. 44 participants did right answer. Okay, so we have Kensi. Print screen. Where is the print screen? Okay, Kensi, Ajay, and Borwan Pop. Are you all here? Okay, yeah. Can you please all come here? Oh, congratulations. Yeah. Yeah, let's come over here. Just one photo. This one. Fuzzy? Okay, thank you. Your emails are properly registered in Concord, right? Okay, so you please share your email ID and your number, name. Maybe we will, yeah, we will let you know.
I am already registered on.
Okay, so we have 50% Kubernetes certification voucher for next 3 participants. If you are interested, maybe please raise. Otherwise, maybe we can give it to next participants as well. For Cyril, Asanka, and Jagadishan, are you here? Okay, yeah, please come over here if you are interested to take 50%.
The two, which is the third one.
Yeah. Yeah, can you please come and join here? Oh, yeah, you don't want? Oh, okay. Okay. Thank you. Ah. Thank you. Okay, just a minute, guys. Can I have one group photo? Excuse me.
Please come in.
Excuse me. Can I come over here for a group photo?
Can stand this side.